Hello everyone, welcome back to my YouTube channel. In today's tutorial, I'm going to show you how to predict future land use land cover using MOLUSCE plugin in QGIS. First, we'll start with data preparation in ArcGIS, then we'll move to QGIS to show you the process to predict future land use land cover. Let's get started. To start preparing the data, we need at least two historical land use land cover and digital elevation models, slope map, distance from river, distance from road, and also you can add population map. Okay, let's import our data. We'll start with digital elevation models. Okay, navigate to where our data saved. We'll start with DEM, digital elevation model. These are digital elevation models I have downloaded from USGS and projected to UTM. If you don't know how to download digital elevation models, I have already created a tutorial showing how to download digital elevation models from different sources from USGS and from Diva GIS. The digital elevation models. Make sure that is projected to UTM zone. Click here. Properties, check, is projected to UTM zone 36 north. It's the location where the basin is full. Right now we have digital elevation model. We can prepare slope map. Go to spatial analysis tool. In spatial analysis tool, go to service. In service slope, add the input raster as digital elevation model, and the output folder will select the location where our data is saved in E drive. Select SWAT model, future LULC. Here, write slope map .tif. Okay. The output measurement will select percentage rise. Okay. Yes, the slope map has been created and we can reclassify it as I already prepared LULC with 10 classes. We can reclassify it from here, property, go to symbology. In symbology, we can select 10 classes, apply. Okay, now we have 10 classes over here. After we prepare a slope map, we need to prepare distance from river, distance from road. To prepare distance from river and distance from road, we have to import the shape files into ArcGIS. Import. We have roads. First, we'll start with road. Okay. This is the road that cover two countries, Sudan and Ethiopia. We need to extract this region using shapefile. Add shapefile from here. Go back. Data preparation. I have the Blue Nile Basin shapefile here. Okay. Right now I have the shapefile. Close the slope. Change the color and check this one. Zoom. We need to extract this region using clip feature. Processing, clip, input feature, road, and the clip feature is basin, and the output is the same location where our file is, right? Road map. and its feature. Save. Okay. Okay, done. Uncheck the road. Now we have the road mosaic to our basin. Uncheck the basin to see it clearly. Okay. Yes. So right now we have the road is ready. We need to prepare distance from road. Select distance from distance, Euclidean distance. Yes. The input raster, select roadmap, the output road, dot if. Okay. And go to environment, processing extension. Here select the extension as basin and select raster analysis. In raster analysis, we want to mask using basin. Okay. And select OK. Yes. The roadmap has been created. Uncheck the road. And after that, we need to prepare the distance from river. Import river shape file. Go back. Go back. Feature. This is a river shape file. Uncheck road. We need to extract the river shape file. Processing. Select clip. In clip, we add the feature as input raster and clip feature basin. Output, same location. River map. Okay. Okay. Now extract it and check this one. This is a river shape file. Again, select Euclidean distance. Double click. Input raster or feature. Select river map. Output river distance dot diff. Okay. And environment processing extent. From here, we select basin, Blue Nile Basin. Go to raster analysis. In raster analysis, we mask the area with a shape file. Okay. Done. Okay. Now the distance from river has been created. Okay. And check the basin. Yes. Right now we have basins ready, slope map ready, and digital elevation models ready, and slope map is ready. And I already prepared different land use land cover of 2015, 2020, and 2025. Let me import the LULC 2015, 2020, 2025. Those are three map I have prepared. Okay, different LULC map, and we need to reproject the river slope and road distance. And before that, you have to check whether the data is projected to your location. The slope map is already projected to UTM because it's reproduced from a digital elevation model, which is already projected to UTM zone. But road distance and slope need to be projected to UTM. Here, it is projected to WGS 1984, and we need to project to UTM zone. Go to data management tool. In data management tool, projection and transformation, project here. Select the feature you want to project. Let's start with road, project, and save it to road map, road.tif. Save. Output coordinate system, projected coordinate system, UTM zone, North Hemisphere, 36. Okay. Rest are fine and select OK. Now road is projected and river is already projected because it's reproduced from the river shape file which is already projected to my location. Check. Yes, because it's reproduced from the shape file, this feature, and the feature shape file is already projected. So it takes same character of the shape file. Okay. Now all data are ready to be used in QGIS. We have three different LULC for 2015, 2020, and 2025. And distance from river are ready. Road map is ready and slope map as well. And we have digital elevation model. Now all the data are ready. We can open QGIS. QGIS. Okay. And make sure that to download QGIS 2.16 or less because MOLUSCE plugin is not working in the newest version of QGIS. Project, new project, select plugin and select manage and install plugin because we need to import or install MOLUSCE plugin into QGIS. Manage and search for MOLUSCE plugin. This one I already installed it. In your case, if it's not installed, select MOLUSCE and reinstall it or install. This option will be installed. As long as I already installed it, it's asking me to reinstall or uninstall. Okay. Cancel. Select raster, and before go to raster we need to import the input file into QGIS. Select this option and go to E in E SWAT model. In SWAT model future, select DEM LULC 2015, 20, 2025, and also we need distance from road and distance from river and slope map. Okay, so we have slope, road distance. We have to add river distance is missing. We have to add it. Select here river distance. Yes, river distance file is added. Okay. Okay. First, let's change the color. Go to land use 2015, double click, change it to single pan. Here, equal interval, apply. Okay. Uncheck, uncheck, uncheck this. Yes, this the LULC 2015. Double click 2015, single pan, mode, interval, apply. Okay. And third one, double click, gray to single pan, mode, equal interval. Okay. But it's classified into five. Again, general, style, equal interval, 10 class, apply. Okay. Equal interval, 10 class, apply. Okay. 2015, equal interval, 10 class, apply. Okay. Then go to raster, go to MOLUSCE plugin, and here we have digital elevation model, LULC 2015, 2020, 25, river distance, road distance, and slope map. First, the initial data will select LULC 2015. Okay, import LULC 2015. The year by default has been added, and 2020 it's final, and also the date has been added. And here in a special variable we add all other variable we have created: dm, river, road, slope. If you have population, density, aspect, map, whatever map you want to include, you add it here. Select dm, add, distance, river, add, road, add, and slope map, add. If you want remove any of those data, you can remove it from here, or you can remove, select one and remove, or remove it all. And then we have to check the geometry here. If the data are not having the same shape, it will show some error. Okay, geometry of the raster are matched. That's mean all data over here are having same geometry because I used same shape file to extract all the data. Okay, we'll go to next step is evaluating correlation. After loading the data, the first important step is correlating evaluation. This tells us how strong each driving factor influence land use, land cover. And here, MLUS blogging is offering three methods: person correlation, Karmar's coefficient, and joint information uncertainty. The person correlation measure linear correlation between the driving factors and land use, land cover, and Karmer coefficients based for categorical data shows association between land cover change and other categorical drive. Finally, joint information uncertainty is measure how much uncertainty is reduced when you use driver variable. Select person and you can select whatever method you want or select persons correlation based on the linear correlation and check. And after we check the correlation, we'll go to next step is area changes. This shows the changes in area of each land cover class between the first and the second year. For example, how much forest turned it into agriculture or how much urban area increased. Why this step is important? It allows us to understand which classes are increasing or decreasing, and MOLUSCE use this information to predict trend into the future and also help you manually adjust transition probability if needed. And in changes area, we can change the raster unit over here either to raster unit or square kilometer or in hectare. Leave it as it is. And if you want to change it to square kilometer, you can change it from here and then select update tables. Now the table updated, and here the map of 2015 and 2020. Here the changes of the map, and we have percentage changes over here, and from this percentage will create land use land cover map. Create changes map, right? LULC change. Changes has been created, and we'll go to next step. Now we come to one of the most crucial parts, and in this step the model learns the probability of each land cover class changing into another based on the driving factor. And in transition potential modeling we have option to define samples. Here we have different options. Either we'll go with random or stratified. And we have the number of sample over here. We can increase it to 1,000 or more. And here we have three options: artificial neural network, a multi-layer perceptron, and there is other method listed over here: weights of evidence, multi-criteria evaluation, and logistic regression. And it's up to you to select whatever method you want to implement in your study. I will go with ANN, artificial neural network. Now we can train the neural network. Select train neural network. Now the model is start training. We see the green line is training and the red color is validation. And you have over here an option to save your model. And over here you see the result of the current validation, kappa, and other result. Now training and validation has been done. We can go to the next step to automate the simulation. Uncheck this option and then we'll predict LULC. So we'll write LULC prediction. Same for 2000. And make sure to write the year 2025. 2025 dot diff. Why I select 2025? Because I already have the observe LULC of the 2025. In next step, I will use the observe LULC of the 2025, and then I will validate it against the predicted LULC of 2025. This will show how much the model is able to predict LULC of the 2025. Save and start. And here you have the number of simulation iteration you can increase. This also will increase the probability of the model to predict good result. Start. Now the model is predicting LULC for 2025. It will take some time to finalize. Now the prediction is done. We'll go to next step for validation. And to validate the model first, we need to add the LULC of 2025. This is the observe LULC against the predicted LULC for 2025. And here we can specify the number of iteration. From here it's written 5. I will leave it 5. You can increase this one or decrease. And then we'll start validate our model. Now the validation is started. After the validation is done, we'll calculate kappa. For calculating kappa in this section, we have different factor. The percentage of the correctness. This is the simplest metric. It shows the percentage of pixels that were correctly predicted compared to the reference map. For example, if your model predict forest in the same place where the 2025 map shows forest, that pixel is counted as correct. And the second option is the kappa overall, and it is the most accuracy measure, and it compares your prediction with the reference map while accounting for the possibility that some agreement may happen by chance. A kappa value of 1 means perfect agreement between prediction and validation. And the third option is the kappa histogram, and the kappa histogram looks only as a distribution of categories, and it compares the quantity of each land cover classes between the prediction and preference map without considering their spatial location. Last one is the kappa location, and kappa location focus on the spatial placement of land cover changes, and it check whether the model predict changes in the right place even if the overall quantity were correct. Now validation is done and we can calculate kappa. And as we see here, we are targeting kappa overall, which is 0.77. If you get more than 0.8, it will give you better performance. And to get more validation kappa, you can increase the number of simulation iteration over here. You can make it 10, 100. This will increase the chance of getting good result. And when you get satisfied that your model are accurately predicting the observed LULC with the predicted one, you can directly go back to the automating simulation and change the land use land cover prediction to 2030 or whatever year you want to predict, and change the year to 2030 and predict your model with the same previous information. If the number of iteration of the previous prediction is 1, when you come to predict another LULC, you have to use the same iteration. And I'm aiming to predict LULC of 2030. Start. Now start predicting LULC of 2030, and after LULC of 2030 I can predict LULC of 2030 2035. And it is better that when you are predicting LULC, you have to predict in equal time interval. It is not mandatory, but to ensure the reliable prediction. Now the prediction has been done. We can write 2025 and start simulation. Yes, done. And we cannot do validation again because we don't have LULC for 2035. This how to predict future LULC in QGIS using MOLUSCE plugin. If you like this tutorial, like, share, and subscribe. If you have any question, leave it in the comment below. See you next tutorial.